Welcome to using Network Configuration Assistant to configure ZERT policy enforcement. In this presentation, we'll start by introducing ZERT Policy Enforcement and Network Configuration Assistant, also known as NCA. Then we'll discuss the ZERT policy rules and the NCA object structure of ZERT. After that, we'll use NCA screenshots to show you how to create various objects and rules in ZERT, and then we'll show you how to install your rules to Policy Agent. Finally, we'll finish by discussing ZERT reports you can use to analyze your NCA ZERT configuration. All right, let's talk about Introduction to ZERT Policy Enforcement and NCA. ZERT policy-based enforcement takes the final step in the ZERT technology journey. ZERT was first introduced in ZOS v2r3 with the discovery function, which creates SMF records that allow you to monitor and report on the state of encryption and authentication for connections that terminate on your ZOS host. ZERT aggregation allows you to streamline the amount of SMF data that ZERT generates, and ZERT Network Analyzer is a ZOSMF plugin that helps you explore the SMF data created by ZERT. One of the most common requests we received when customers saw ZERT was the ability to have the stack automatically take enforcement action based on ZERT data. They said, you know these connections don't meet the standard, so do something about them. ZERT policy-based enforcement provides that last piece of the puzzle. You can define ZERT enforcement rules to instruct the TCP/IP stack to take actions on connections based on their encryption and authentication characteristics, ranging from allow silently to write an SMF record to terminate the connection. This presentation is a deep dive on using Network Configuration Assistant to configure ZERT rules. For a detailed introduction to the overall ZERT function, see session Z203709, which was given earlier this week and is available as a recording. The Network Configuration Assistant is a GUI tool to simplify various configuration tasks in ZOS Communication Server. It handles configuration of policy-based networking technologies, which include multiple security technologies, as well as quality of service and policy-based routing. You can also configure the TCP/IP profile using NCA. ZERT enforcement is a new policy discipline that IBM has added to NCA for v2r5 in support of the new ZERT policy-based enforcement function. To access the Network Configuration Assistant, double-click on its icon on the ZOSMF desktop as shown here. That brings you to the NCA opening screen where you choose which backing store to work on. You can select an existing backing store, or you can create a new backing store, or you can import one from another system. The backing store is the file where NCA stores its configuration data. It is not the configuration that NCA generates. That is a separate file that NCA generates based on the configuration that you create and save in the backing store. The opening screen also contains quick links to useful files, help files, including the What's New file that tells you what new function is included, and various tutorials. This screenshot shows the TCP/IP technologies configured by Network Configuration Assistant. The first 8 shown in this dropdown are already existing technologies in NCA. The last one, ZERT, is for ZERT policy enforcement and is the focus of this presentation. The systems tree defines the layout of your systems, sysplexes, ZOS images, and TCP/IP stacks. You create this by adding elements using the actions pull down. This tree is shared by all of the technologies that are configured in the backing store. To configure a stack, sysplex, or image, you select it and pull down the Actions menu. Which configuring options are available depends on what technology you are configuring, for example, ZERT, TCP/IP stack, ATTLS, quality of service, etc. Now let's introduce the concepts of ZERT policy rules and object structure. If you're already using IBM's policy-based networking on ZOS, you'll need to understand the ways that ZERT rules compare to policy rules in other disciplines such as ATTLS, IPsec, policy-based routing, etc. In most other policy disciplines, incoming or outgoing packets are examined against the policy rules to determine what action, if any, to take. ATTLS is the exception to this as it is TCP connection oriented. In ZERT policy enforcement, TCP connections are examined against policy rules to determine what action, if any, to take. This is similar to ATTLS. This means that ZERT rules are not consulted as often as most other technology rules by the TCP/IP stack. In ZERT policy enforcement, connections are examined after they are established. This is required to allow time for the security protocol of the connection to be established and learned by ZERT. This time delay can range from almost immediately to 10 seconds, depending on several factors that are described in the detailed ZERT presentation mentioned earlier in this presentation and given earlier in the conference. What's important to us is this means ZERT rules are reactive, not proactive. They act on connections that are already established. Connections are also re-examined if the security characteristics change significantly during the life of the connection. For example, FTP starts out in clear text and then can send a command on the control connection to start TLS, then later can send another command on the control connection to stop TLS. In that case, this connection is examined 3 times. Another key difference between ZERT and most other policy technologies is that multiple ZERT rules can apply to a connection. In most other policy technologies, a packet is examined against a single ordered list of rules, and the first rule that is found that matches the packet is used to determine how to handle that packet. In ZERT, a connection is examined against a list of rules for each security protocol that is active on that connection. The first rule that matches the connection in each applicable security protocol is used. For example, if a connection is protected using both TLS and IPsec, then it is examined against the list of TLS rules and against the IPsec rules. The first rule in each of those lists that applies to the connection is used to determine actions for that connection. This means that in ZERT, the order of rules within a security protocol is significant, but the order of rules between security protocols is not. ZERT rules are divided into security protocols. For NCA, they are further divided into rule types. The security protocols for ZERT rules are TLS, IPsec, SSH, and no recognized protection. Note that for no recognized protection, the traffic may not really be unprotected. It could have a level of protection not recognized by ZERT, for example, application level encryption. No recognized protection only indicates that ZERT could not recognize any protection. Then, within a security protocol, NCA introduces the concept of 3 rule types. A general rule specifies a set of attributes for a protection protocol that meet your local security requirements. There is potentially one of these in each ZERT rule set. It is not specific to any traffic types, so does not contain traffic information. The general rule is optional. A customer could define only specific rules in a rule set. General rules are not used for connections with no recognized protection because these connections do not have security characteristics to evaluate. Specific rules are hierarchically under the general rule for a protection protocol. Specific rules represent exceptions to the general rule, and they describe connections that did not meet the general rule and that require special handling. These rules are evaluated in the order in which they are specified in the NCA, top to bottom. The catch-all rule matches all connections for the protection protocol that don't match the general rule or any specific rules. These are usually connections that require some attention because they didn't meet your overall standards or any of the exceptions that you described in specific rules. These rules will be generated for you by NCA. It's important to remember that in Policy Agent, these are all simply rules. NCA users work with these types of rules in the GUI, and NCA will provide the appropriate configuration in each rule to implement the type. These rule types are best explained with examples, which we will show on the following slides. In this example, we look at a use case for all 3 of our rule types. In this example, the enterprise's standard is that TLS traffic should be using at least TLS version 1.2. However, for whatever reason, Telnet is still using TLS 1.1. This may be a temporary condition, as Telnet may be in the process of being upgraded. However, since there can be thousands of Telnet clients spread all over the enterprise, this migration isn't yet finished, so Telnet has an exception to continue using TLS 1.1 until the upgrade is complete. This slide illustrates a rule set that accomplishes that use case. The general rule is the first one in the hierarchy, so any TLS connections using TLS 1.2 or 1.3 match it and are permitted with no action. Similar to policy rules in other technologies, the first rule within a rule set that matches is the one used, so connections that match the general rule are permitted with no further ZERT policy action and no further ZERT TLS rules being examined. For connections that do not match the general rule, the specific rules are examined in order and the first matching rule is used. In this example, if the connection is to the Telnet port, which is port 23, and it is using TLS 1.1, it is also permitted with no further action. Any TLS connections that don't match either the general or the specific rule do not meet the enterprise's TLS standard and are of concern. They will match the catch-all rule, which in this case causes an audit record to be generated so that you can follow up on it later. This use case illustrates that general rules are optional. In this use case, the customer wants to ensure that all telnet connections are protected by TLS version 1.2 or higher. The customer does not care about the TLS protection level for any other applications connections. In this case, there is no general rule in the TLS rule set, only specific rules for the connection types that the customer wants to monitor. The first specific rule will permit, with no action, any telnet connection that is protected with TLS 1.2 or 1.3. The next specific rule will generate an audit record for any telnet connection protected with a lower level of TLS. Remember that the rules are evaluated in order, so any telnet connections that reach the second rule would not be at TLS 1.2 or 1.3. If they were, the first rule would have matched. Finally, for all other connections protected by TLS, permit them with no action since they are not of monitoring interest. This slide shows how a customer might handle connections with no recognized protection. These may be in the clear, but if they're using application level encryption, ZERT will not be able to recognize that protection either. NCA does not support general rules for no recognized protection because these connections do not have any encryption characteristics to examine. NCA only supports specific rules and catch-all rules for these connections. One example of a use case in which clear text might be acceptable is a hypersockets network. Since this network is completely contained within a KEK with no external access, you might decide the traffic there does not require protection. So you might write a no recognized protection specific rule permitting, with no action, connections to or from the hypersockets network as shown in the first rule here. Another example of a use case in which clear text might be acceptable is a case we call discretionary TLS. Discretionary TLS simply means that the application is permitted to turn TLS on and off during the life of the connection. The most common example of this is FTP, which generally starts in the clear and then uses control commands to begin a TLS session. Then the client may decide to turn off TLS because it is no longer required. CS-SMTP, Connect Direct, and TN3270 with negotiated security coded are additional examples of applications with this behavior. Because of this behavior, it is acceptable for connections of these types to use clear text, but they may also be required to use specific characteristics of TLS when they are using TLS. Recall that ZERT is notified whenever the encryption characteristics of a connection are changed. This means the same connection may be alternatively reported to ZERT as using TLS and as having no recognized protection. To account for this, you need both TLS rules and no recognized protection rules for these types of connections. In the example on this slide, the no recognized protection rule for FTP is added to the no recognized protection rule set. It is assumed there is also a TLS rule for FTP. NCA will help you make sure both of these rules are present in this case. Finally, any other connections with no recognized protection require investigation. These are probably the connections you are interested in tracking down to understand why they are not protected, and then to either work with the communication partner to implement appropriate protection or create a new specific no recognized protection rule to silently permit the traffic. The catch-all rule for this rule set generates an audit record to help you track these down. A general rule describes the generally acceptable requirements for your network for a specific security protocol. Because it describes what's generally acceptable, a general rule does not contain specific connection information such as ports, addresses, direction, etc. A general rule contains one or more protection characteristics objects, including protocol versions such as TLS version or SSH version, and a general rule action, which will usually be to permit silently. A specific rule describes how to handle specific connection traffic that did not match the general rule. Because it is for specific connection traffic, a specific rule can contain traffic descriptors and address groups. These objects are similar to the NCA objects of the same name in other NCA perspectives. A traffic descriptor describes workload traffic in terms of ports, direction, and optionally, job name and user ID. An address group is a list of one or more addresses, ranges, or prefix, also known as subnets. A single address, range, or prefix can also be specified directly into a specific rule, eliminating the need for a separate object. A specific rule for no recognized protection is similar to specific rules for the other security protocols. However, because it's a rule for connection traffic with no recognized protection, by definition, it does not contain protection characteristics. Catch-all rules contain only a protocol specification and an action. In the NCA GUI, users specify the catch-all rule directly in the rule sets. NCA will use that information to generate a catch-all rule. This simplifies the number of rules and objects that a user maintains. Note that the catch-all rule will be generated even if the action is to allow silently, which is the default action, so users can see the results of their settings in the configuration file. All right, the next most important object is the ZERT rule set. The ZERT rule set is an NCA container that helps users organize rules in a hierarchy and then to share that organization across stacks. ZERT rules are always grouped together into rule sets for associating to stacks, and ZERT rule sets are reusable across stacks. A ZERT rule set is always for one specific security protocol. A stack can have one ZERT rule set associated to it for each security protocol, which means that the maximum number of rule sets that can be associated to a specific stack is 4. In NCA, a ZERT rule set can contain 3 types of rules for its security protocol: 0 or 1 general rules, 0, 1, or multiple specific rules, and 1 catch-all rule. The catch-all rule is not a separate rule object. It's specified directly in the rule set and generated for you by NCA. If you have used the NCA IPsec technology discipline, you may already be familiar with the concept of reusable policy rules. ZERT takes this a step further by making all ZERT rules reusable. Stack-specific rules are not supported in ZERT. Similarly, all ZERT rule sets are reusable. Stack-specific rule sets are not supported in ZERT. When you modify a rule or a rule set, the change you make automatically ripples into all stacks that use that rule or rule set. The next time you install the configuration file, those changes take effect in Policy Agent. This slide illustrates the object relationship between rules, rule sets, and stacks in NCA ZERT technology. All rules are reusable and they can be added to multiple rule sets. All rule sets are reusable and they can be added to multiple stacks. Rules cannot be added directly to stacks. Only rule sets can be added to stacks. Each stack can have one rule set per security protocol. For example, if a stack has a TLS rule set associated with it, it cannot have a second TLS rule set associated with it. Since there are 4 different security protocols, this means a stack can have at most 4 rule sets associated with it. Since each security protocol rule set is evaluated independently, the order of rule sets in stacks is not significant. Now we'll discuss creating basic ZERT objects in Network Configuration Assistant. Protection characteristics, traffic descriptors, and address groups are objects that can be used to build ZERT rules. We'll discuss each one on the upcoming slides. When you create a protection characteristics object, you give it a name, an optional description, and you select what type of protection characteristics object you are creating. There are 4 types of protection characteristics supported by ZERT technology. Symmetric encryption, which represents algorithms for symmetric encryption of connection traffic. Message authentication objects represent algorithms for message authentication. TLS key exchange objects represent key exchange algorithms for TLS connections. SSH key exchange objects represent key exchange algorithms for SSH connections. The next slide shows an example of configuring a specific protection characteristic object. This is an example of a symmetric encryption protection characteristic. This screenshot only shows the first several selections on the screen. In NCA, you can scroll down to access more algorithms. In a protection characteristic of any type, you can either select, quote, any algorithm, or you can specify algorithms. It's important to understand that when you select any, that includes none. So selecting any algorithm is similar to not specifying the protection characteristic at all. Algorithms are grouped with similar types for convenience, so you can select or deselect them in a group if you prefer. For example, on this slide, we've selected all AES algorithms simply by checking all AES algorithms, and all of the AES algorithms under it were automatically selected. You can also select individual specific algorithms, and you can also deselect individual specific algorithms. You will also notice that no algorithm is always a choice. No algorithm is not mutually exclusive with selecting algorithms. It means that the selected algorithms are optional for this protection characteristic, and this protection characteristic will match if there are no algorithms used or if any of the checked ones are used. After you've selected algorithms for this object, you click Finish, and the object will be created and will be ready to be added to ZERT rules. If you are familiar with NCA's policy configuration technology, you've probably already worked with traffic descriptors. ZERT traffic descriptors are very similar to traffic descriptors in other NCA technologies such as IPsec, ATTLS, and policy-based routing. Since ZERT policy enforcement only supports TCP connections, ZERT traffic descriptors can only describe TCP workloads. IBM provides a large set of traffic descriptors for standard workloads. Before using one of these IBM-supplied traffic descriptors, you should examine it for accuracy in case your installation has changed characteristics of the traffic, for example, which ports it uses. Similar to other NCAA policy technologies, a ZERT traffic descriptor can contain multiple traffic types. A ZERT traffic descriptor that contains multiple traffic types will generate a connection descriptor group statement in the ZERT policy configuration. A ZERT traffic descriptor with only one traffic type will generate a connection descriptor statement in the ZERT policy configuration. On the next slide, we'll examine a ZERT traffic type in more detail. The only IP protocol supported by ZERT is TCP. As you can see from this example, you specify local and remote port or port ranges and connection direction. You can optionally indicate that the traffic uses discretionary TLS, which means that TLS protection can be turned on and off during the life of a connection. You can also optionally specify a job name and/or a user ID. And you can also note, for the example on this slide, that you can use wildcards in the user ID and job name. Address groups provide a convenient way to specify multiple IP addresses in a group. An address group can be included in a ZERT-specific rule as a data endpoint. ZERT address groups are similar to ATTLS address groups and have the following characteristics. First, the following IBM-supplied address groups are always provided: all IP addresses, all IPv4 addresses, and all IPv6 addresses. You can specify single IP addresses, ranges of IP addresses, or IP address prefixes, also known as subnets. A ZERT address group can contain a mixture of IPv4 and IPv6 addresses. You can nest ZERT address groups up to 3 deep. In other words, you can include address groups within address groups. Now we'll discuss creating ZERT rules in the NCA. Remember that all ZERT rules are reusable, so they are created and managed under the Reusable Rules tab on the Systems tree. Within that tab, they are organized in tabs by security protocol: TLS, IPsec, SSH, and no recognized protection. For our example in this presentation, we'll show you the creation of a TLS rule. You create a new ZERT rule in NCA using a wizard. The security protocol of the rule is determined by which security protocol tab you're in when you start the creation wizard. In this example, we are in the TLS tab, so we'll be creating a TLS rule. The first thing you do is give the rule a name and optionally a description. You also select whether it's a general or a specific rule. For this example, we'll be creating a TLS general rule. Remember that a general rule does not include traffic descriptors or address groups because it describes generally acceptable protection and is not for specific traffic. After you have named your rule and indicated that it's a general rule, you pick its protection characteristics. These are the generally acceptable characteristics for encryption, key exchange, and authentication in your network. For TLS, you can select TLS versions, and then you can pick from the defined protection characteristics objects as shown in this slide. It's not shown in this slide, but you can also pull down Actions New on the protection characteristics table to create a new protection characteristic if a suitable one doesn't already exist in your configuration. The last panel of the new rule wizard is to pick the action that the TCP/IP stack is to take for traffic that matches the rule. Since the general rule describes what's generally acceptable in your network, that action is usually to allow silently, which is the default selection shown here. After you click Finish, the rule is created in the list of reusable TLS rules. As an example of a specific rule use case, let's assume that, even though our general rule required TLS 1.2 or 1.3, Telnet is still allowed to use TLS 1.1 because there are thousands of clients in the network that are still being upgraded to more modern TLS. Until those upgrades are complete, TLS needs to be allowed to use TLS 1.1. We will create a specific rule to cover that use case. Like the general rule, we have to give this rule a name, and we can optionally give it a description. Then we select that it is a specific rule. Notice that when we select that it is a specific rule, traffic descriptors and data endpoints are added to the wizard flow. Because this is a specific rule for specific traffic, it supports these additional elements. Because this specific rule is for TN3270 traffic, we will use the IBM supplied traffic descriptor for the TN3270 server. Note that when using IBM supplied traffic descriptors, you should first verify that they are correct for your workload. The IBM supplied traffic descriptors contain default port information, and if you've changed the port that the workload uses in your network, you will need to update the IBM supplied traffic descriptor. The data endpoint describes the IP addresses, prefix, or ranges that the rule applies to. In our example, the rule applies to all TN3270 traffic, so specifying the TN3270 traffic descriptor is sufficient. No data endpoint needs to be specified, so the default values of all IP addresses can be used for this rule. Now, what are some use cases where you would specify a data endpoint in a specific rule? Here's a couple of examples. You might have a specific section of your network, for example, your hypersockets network or within the sysplex, that can use a lower level encryption than your general rule. Or you might have a specific business partner who hasn't yet implemented encryption to the level that you generally require, but for business reasons, you still need to let them attach, and you don't need to be notified each time they do. In that case, you could specify their IP addresses, prefixes, or ranges as the remote data endpoint. Both the traffic descriptor and the data endpoint, while supported in specific rules, are optional. You may not need the data endpoint if, as in our example here, the traffic descriptor adequately describes all the connections of interest. On the other hand, if you are creating a rule for specific partners or networks, no matter which workload they are using, the data endpoint is a sufficient description and no traffic descriptors would be needed. Also consider this use case where neither may be coded in a specific rule. You want to terminate connections using really old versions of TLS like SSL-v2 and SSL-v3. Specifying those TLS versions in the protection characteristics is sufficient to describe the traffic that this specific rule will apply to. Recall, we are creating a specific rule to allow TN3270 to use TLS 1.1. So for this rule, we select that version of TLS and any other protection characteristics objects that match what we want to see from this traffic that we're going to allow. Note that just like in the general rule, you can pull down actions new and create a new protection characteristics object if the one you need is not already in the list. In our example, we're creating a specific rule to allow Telnet to use TLS 1.1 without any action. So the appropriate action for this specific rule is the same as the general rule, which is to allow the traffic with no action. In other words, no auditing or logging. What are some examples of use cases where other actions might be appropriate? Well, you could want to monitor the progress of the upgrade of this traffic, so you might want an audit or log action. You could be creating a rule to completely ban very down levels of TLS, for example, SSL-v2 or SSL-v3. In that case, you might choose to reset connections that match this rule. When you choose to reset connections, you should also specify one of the actions to log it, the console or syslog-d, so you have some notification that the connection was terminated and why. Also, keep in mind that this action will reset a connection after it has been established. It does not permit the initial establishment of the connection. You can continue creating additional rules for TLS or for IPsec, SSH, or no recognized protection. You can create multiple general and specific rules on these panels. You just need to maneuver between the tabs here to create rules for different security protocols. Note that to use these rules in stacks, you first have to put them into rule sets, which we will discuss in the next few slides. Also note that you do not create catch-all rules here. These are automatically created by NCA as part of rule set creation, which we will cover in the next section. Now we will discuss creating ZERT rule sets in the Network Configuration Assistant. A ZERT rule set represents a hierarchical organization of reusable ZERT rules for a specific security protocol. The rule set itself is reusable, and once created can be associated with multiple stacks, which we will see in the next section. When you create a rule set, you give it a name, an optional description, and you specify which security protocol the rule set is for. Then, you click Next to start associating rules with the rule set. The next thing you do when creating a rule set is to specify the general rule. A general rule is not required, or you can select from the list of reusable general rules already created for the security protocol. If none of the existing general rules is suitable, you can pull down Actions New and create a new reusable general rule, which will be added to this rule set and will also be able to be added to other rule sets of the same security protocol. Once you have selected or created a general rule, you click Next to go to the Specific Rules panel. After selecting the general rule, you next select the specific rules for the rule set. Remember that the specific rules represent exceptions to the general rule. They will be evaluated after the general rule is evaluated, so only connections that do not match the general rule, if the rule set has one, will be evaluated against specific rules. The specific rules are evaluated in order, and the first one that matches the connection being evaluated is used. In this table, all existing specific rules for this security protocol are presented to you with checkboxes. You simply click on the rows for the specific rules you want to add to this rule set. If you need to create a new specific rule for this rule set, you can pull down Actions New and create a new reusable specific rule for this security protocol. This rule will then be available for use in this and in any other rule set that uses the security protocol. The specific rules will be evaluated by ZERT in the order in which they are specified in this rule set. If you need to adjust the evaluation order of the specific rules chosen for this rule set, you can pull down Actions Order Selected Rules to bring up a panel that will let you change the order of the rules you have selected. When you have finished with the specific rules, you next specify the catch-all action for the rule set. The catch-all rule tells ZERT what to do about connections for the rule set security protocol that don't match the general rule or any of the specific rules. These are connections that don't meet your general standards and didn't have any exceptions coded for them. In general, these are the connections that will most likely require further investigation on your part. The same actions are available for a rule set catch-all action as are available for reusable rules. As in reusable rules, if you do not allow the connection silently, you can select from 4 actions. You can select from 1, multiple, or all of the available actions. Notice that you do not create a catch-all rule in NCA ZERT technology. Instead, you simply specify the catch-all action for a rule set, and NCA will automatically generate a catch-all rule and guarantee it is evaluated after the general rule and all specific rules for the security technology of this rule set. You can use this flow to create rule sets for all 4 supported security protocols: TLS, IPsec, SSH, and no recognized protection. The only difference is that no recognized protection rule sets do not have general rules. You can create as many rule sets for each security protocol as you need. The rule sets become effective when they are associated with TCP/IP stacks and installed, which we will cover next. Now we'll show you how to associate rule sets to stacks in NCA and how to generate policy agent configuration. To add rule sets to a stack, you open its rule set panel as shown here. This slide also illustrates that you can take actions on a stack either by selecting it and pulling down the Actions menu or by right-clicking it. The Rule Sets panel contains a table that presents all of the reusable rule sets to you. You simply click on the ones you want to associate with this stack to add them. In this example, we have selected 2 rule sets for Stack 1, TLS-RS-production and NRP-production. As their names imply, these are rule sets for production traffic. You can see on the slide we have created 2 additional rule sets, a TLS rule set for the sandbox environment and a no recognized protection rule for the sandbox environment. These are currently grayed out because a TLS rule set and a no recognized protection rule set have already been selected for this stack. You can only associate 1 rule set per security protocol to a stack. This also means that a stack can have at most 4 rule sets associated with it. In this page, if you were to click on the TLS-RS-production rule set again to deselect it, both TLS rule sets in the list would again become available for selection until you selected one, and then the other one would again become available. In this manner, you can create multiple rule sets for multiple use cases. For example, as we showed here, production versus sandbox, or any other set of use cases you might have, like banking versus credit card, etc. Then you would use this interface to associate the appropriate rule sets to each of your stacks. A stack is complete and available for installation when it has at least 1 rule set associated with it and it's in an image that's at level V2R5 or greater. You can associate rule sets to stacks that are a lower release level than V2R5, but you can't install them. This way, you can down-level an image in NCA without losing its stack's ZERT configuration, or you can pre-configure a down-level image's stacks with ZERT rules that take effect when it is upgraded to v2r5. Installing a configuration file means generating the actual policy configuration file and placing it into the file system of a ZOS image to be read by the policy agent. In this action, Install all files for this group, you have a table listing all of the configuration files available to install. You can also view the generated configuration file from this panel. We won't show the entire configuration panel in this presentation, but we'll point out some highlights. NCA automatically creates ZERT action objects for all of the action combinations that you selected in rules and rule sets. Their generated names list the actions selected. NCA ZERT includes comments in the configuration file. For any object with a description field in the GUI, if you provide a description, that description will be used in the configuration file as a comment for that object. Even though in the ZERT configuration file the objects that describe workloads are called connection descriptors, the GUI used the term traffic descriptors to maintain consistency with other ZERT technologies. But keep in mind that in ZERT it is connections, not packets, that are evaluated. NCA ZERT technology will generate objects to represent your protection characteristics objects from the GUI. The type of object generated depends on the type of protection characteristic object you used in the GUI. The table in this slide shows which configuration file object types are generated for each type of protection characteristic supported by NCA ZERT. So if the NCA ZERT GUI you've created a symmetric encryption protection characteristic object, that will result in a ZERT symmetric encryption statement in the configuration file. If in the GUI you've created a message authentication object, that will result in a ZERT message authentication statement in the configuration file. If you've created a TLS key exchange object in the GUI, that will result in a ZERT key exchange statement in the configuration file, but it'll contain TLS key exchange parameters. Finally, if you create an SSH key exchange object in the GUI, that will result in a configuration statement of ZERT key exchange, and it will contain SSH key exchange parameters. Recall that rule sets are an NCA concept for organizing your ZERT rules. Policy Agent has no concept of rule sets, only of rules. When NCA ZERT generates the configuration file, it generates rules according to your rule sets. The rules for each security protocol are grouped together in the generated configuration file and are listed in priority order according to how you organize them in the rule set. The general rule, if provided, is the highest priority rule of a security protocol, and it is first. Then the specific rules are listed in priority order, and finally the generated catch-all rule is the lowest priority rule in a rule set. Priority is obviously important within a security protocol. However, between security protocols it's arbitrary because each relevant security protocol is individually evaluated for a connection. By convention, NCA assigns priority values to rules by security protocol using the following numbering scheme. TLS rules will get priorities 400,000 to 499,999. IPsec rules will get priorities ranging from 300,000 to 399,999. SSH rules will receive priorities ranging from 200,000 to 299,999. And finally, no recognized protection rules will receive priorities ranging from 100,000 to 199,999. The installation panel, which actually pushes the generated policy configuration file to the file system of a ZOS image, works the same way as it does for all other NCA technology perspectives. NCA can save the configuration file onto the local disk of the ZOS image in which NCA is running, or you can FTP the file to any ZOS image that can be reached using FTP. In this manner, a single NCA instance can manage ZERT policy configuration for multiple hosts. If you're in a sysplex with shared disk access, you can use save to disk to distribute the configuration to the members of the sysplex, and you can always use FTP to distribute configuration to multiple systems. Like other ZERT technology perspectives, NCA ZERT supports multiple installation. Once installation parameters are configured for stacks, you can install an updated ZERT configuration onto multiple systems with a single GUI action. Finally, we'll discuss NCA reports that you can use to analyze your ZERT configuration. View details and show where used are useful reports that NCA provides to help you analyze your configuration. They are provided throughout NCA in all NCA perspectives, including the new ZERT perspective. View details provides a formatted detailed report about an object in NCA. It gives you a quick way to see the characteristics of an object and what other objects it contains, if any. Show where used shows you where an object is used and where it is referenced by other objects in NCA ZERT. It's an important report because you cannot delete an object that is used by another object. Also, if you change an object, you can use show where used to see what other objects will be changed and affected as a result of that change. More on these two reports in the next two slides. View details provides a detailed, formatted report about an NCA ZERT object, as seen in the example on this slide. The examples on the left show details reports for an address group and for a traffic descriptor. The example on the right shows a view details report for a reusable rule set. You will notice that because the reusable rule set contains reusable rules, the detailed information about those rules is also included in the report. Furthermore, since reusable rules contain other objects like protection characteristics, address groups, and traffic descriptors, those objects are also expanded in the report on the rule, which is included in the report on the rule set. This means that every view details report contains full information about the object being reported on, including objects that it includes. So you can see a comprehensive view of something using view details. This slide shows examples of show where used reports on various ZERT objects. On the left is the report for an address group. Note that in this example, the address group is embedded into another address group, which is in turn embedded into a second address group. So this report shows that hierarchy. It also shows which reusable rules use this address group, and then shows which stacks and rule sets those reusable rules are used in. From this report, you can learn everywhere this address group is used up to the full hierarchy of ZERT objects. Now on the top right is an example of the report for protection characteristics. This report shows you not only which reusable rules use the protection characteristic, but also which stacks and rule sets those rules are used in. Once again, from this report, you can learn everywhere this protection characteristic is used up to the full hierarchy of ZERT objects. The bottom right is the report for a reusable rule. It shows you which rule sets the rule is used by, and then shows you which stacks those rule sets are in. And that's our information about NCA's ZERT support. But ZERT is much more than NCA, and ZERT is a major function of ZOS. IBM has a lot of good information about ZERT online, which you can access using the QR code on this slide. This slide also provides a good summary of the value provided by ZERT. ZOS Communications Server offers several online courses that award open badges upon completion. You can take a course in Networking on ZOS Foundations. You can take a course on ZOS Network Security Foundations. And we also have a course on configuring TCP/IP with NCA. We also have an online community which has a rich amount of technical content, blogs, videos, etc. And you can reach it by using the QR code on this slide. Thank you for your attendance.